So this is a demonstration of running the libEnsemble forces GPU example on Perlmutter. And in the docs you'll find the tutorial for forces GPU, and there's a Perlmutter guide. So I've already created my contra environment here, and I will obviously need the Python module, and then isolate and activate the environment. And then you'll need these modules. So we're going to use Nvidia to compile the forces example. Oops. Need the CUDA toolkit, and this for the right GPU. And now we're just going to install libEnsemble. Just pip install. Now, that's the install I'm going to use. I'm also going to clone the environment simply to get access to the forces example. You could just copy the directory. I'm just going to change drive to libEnsemble test scaling test forces, and you have this. So we're going to go first into the forces app. And first we need to edit forces to make sure that we're running on the GPU. And so I'm just going to uncomment the OMP target teams line and comment out the OMP parallel line. I can actually create this in one so that it falls back to the CPU if the target isn't there, but unfortunately that doesn't work on some of the older versions of OpenMP, so that's why I keep doing this. And if you look in build forces, you'll see there is a Perlmutter build line there for the Nvidia compiler, which is this. I was complaining about how I toggle my comments, but we'll ignore that. Okay, and now I'm going to get an interactive session with salloc. I'm just going to go onto one node, and obviously here you need your project ID with an _G. And now I'm on a node. I'm going to go up into my second shell, it's also on Perlmutter, and just SSH into that node. And then on here, I'm going to do watch. And let's do -n 0.1, so that's every 10th of a second. This will update, and I'm going to run Nvidia NSMI. That will show the 4 GPUs on this node. And I'm going to run forces, and I'm going to give it 200,000 particles rather than default 1,000, just so to make sure it runs long enough to see. And this means it's doing 2 time steps. On the GPU nodes, you always need some explicit GPU option here. I'm just saying GPUs per task equals 1. This, of course, in this case refers to an MPI task or an MPI rank. And we can run that on too, and you should see 2 GPUs in use. Uses 1 per rank. If you want to use NSC profiling, you can run like this. And then you'll get a nice profile. And now let's go to run libEnsemble. So drive to forces GPU. So we go up a directory and into forces GPU. And now I'm going to just edit our sim function. So we don't actually need to use CUDA visible devices because we're going to rely on that GPUs per task option. And we can put that in here. We'll do extra args equals, and then just type it out as a string, GPUs per task equals 1. And the other thing I'm going to do here is I'm going to multiply my particles by 10, because as I say, the default is 1000, and it's probably going to be too quick to actually see it. And that's it. And you will need slurm exact equals 1. This is very important. It will not, otherwise it will give all the resources to the first srun that it does. And so it will only run one at a time. So we need this flag. Of course, you can put that in your script, in your submission script. And now I'll run the libEnsemble forces example with 4 workers. And it's going to do 8 simulations, so it should be pretty quick. And we should see all 4 GPUs in use on this node. So we see that. And then we can just check that the output is okay. All of them run. And you can see there's an ensemble directory that has the output for each simulation in there, as well as what work it ran on. And that's basically it. That's the key demo. And obviously this can be run over many nodes. And with the variable resources feature, whereby you simply tell each simulation when it's created what resources it needs. It'll be the number of resource sets, and that will actually work with this sim function completely unmodified across any number of nodes, partitions, different numbers of partitions on nodes, and individual simulations can be done across nodes. All of that is worked out and scheduled for you. Now, if you want to run using the MPI for Pi rather than the local comms, you will need to compile MPI for Pi under the GNU environment like this. This is the prescribed incantation for building MPI for Pi on Perlmutter. Okay. Make sure I clean up the output. And then the equivalent would be run like this. You notice it's 5 because we're using now one manager. Okay, there you go. Now if you get this, it's quite likely that you've got this flag mpitch GPU support enabled set. Now if you want to set this when you're running with srun here, the problem is it wants you to have a GPU option on this run line when you're running libEnsemble. So the simple answer to that is to put it inside your sim function, which in this case is forces_simf. Just set it there and that works fine. So as I said, this can be replicated on multiple nodes. We can use dynamic resource allocation, and here's also other flags that may be useful. Okay, thank you.